Hi, today we are going to talk about a concept called delegates. Let's see what it is about. Okay, we have the usual ground and the usual avatar on it, and on the avatar we have this component called delegates. So let's see what this is about. There you go. This is the code. As usual, we use Unity Engine so that we can access symbols like mono behavior and the fact that start is a well-known function and stuff like that. That is used to initialize things, like we are using it in this case. So as you can see, there are 4 instructions, right? Now the third and fourth for now are commented out because we uncomment them later and see what they do. The first two. The first defines a type, and the second instantiates that type. So the use of delegates is a two-step process, so to say. Delegates in here is a keyword, like class, like using, like public, like void. It's a keyword in the C# language, so you have to sort of know it. And is a keyword that is used to define types, okay? Not instances yet. The next line, you use the type that you define to instantiate it. You can instantiate as many as you want. Like any type, you can instantiate as many times as you want. In this case, we instantiate it only once to define the delegate called myDelegate with a lowercase m. That is an instance of the myDelegate with an uppercase m. So we use uppercase because in general types have an uppercase letter, right? So again, it's important to stress that all of it is a type. And if you see, it looks like a function because this is a return value, obviously, and these are input parameters. Now, in this specific case, I chose to have a function, right, signature, that returns nothing and has no input parameters. Still, even though there are, for instance, no input parameters, you still have to say it. You have to have the parentheses, even though there's nothing in the middle, you have to say it. Okay, you have to say, I want a function that returns nothing, if that's what you want, of course. You can have a function, as we'll see later, that returns the Boolean, for instance. And it takes nothing in input, okay? Now, this overall is a signature, but the name of it, the token in the middle, right, the name, is actually the one we use to instantiate that delegate. So my delegate becomes a list of functions that have this signature. That's all there is to it. So first I say public delegate with a signature of a certain kind, and then the name of that function signature is used to instantiate a delegate. That nothing else is this thing than a list of functions that have the signature. So look at that. First, my delegate example returns nothing, gets nothing in input. Second, my delegate returns nothing, gets nothing in input. They print something on the screen, right? Not on the screen, on the console, I mean. And so, because my delegate, the instance of my delegate with a capital M, is a list, I use the plus equal operator to append, in a sense, a function, right? So now my delegate is equivalent to these two functions. Like, it's a list of these two functions. So when I execute it, it's like I execute these two functions. So in a sense, it's no different than doing this. So instead of executing my delegate that is a list of these two functions, I can simply execute the two functions. So the advantage is that, if I have many functions here, I only have to call this one, instead of one for each line, right? Okay, so this is just to say that it is the most trivial thing there is. A delegate is an instance of a delegate type that, in its definition, defines the signature of a function, and the function that to add to this list, they have to follow that signature. There's nothing else to it. So here we are literally executing these two functions, all right? And here now we are compiling the code back to Unity. There you go, it's done compiling. So let's see in the console, we press play. And we imagine that we see my delegate first and my delegate second, right? First my delegate, second my delegate. Nothing surprising here. Only start is executing, right? So why nothing else should happen? It's not like in update that keeps repeating. It just does it once. So first we load, we append the two functions inside this delegate. We make sure that these two functions have the signature here, the same of the delegate. Nothing, so to say. And then we execute it. So just to give you a sense that, the delegates can be of any type, really, I defined also another one. For instance, this one says again, public delegate, exactly like the first, defines a type. This is the type that has this signature. Returns Boolean, takes an int. It could have more input, right? Could be different output, could be float, anything. And of course we give it a different name because the type is orange, right? And before the convention that it has capitalized letter. Then the next line, the fourth line, when we instantiate it, we call it the same name with the lowercase letter because that's again the convention for local variables. And here, first we load it in a sense. See, we can say equal or plus equal is the same thing. For the first one is the same. For the other ones, if here we said equal, it would override this one, right? It would delete the first and put this second would take the place of the first instead of appending to it. And so in general, we tend to do always plus equal. This way, for instance, I want to put this one after, I don't have to rewrite the code, right? Because then I have to say, oh no, this is the one that has the equal only, right? And things like that. So we use plus equal typically for everything, and that's it. All right, and then we execute it. Now, because it takes an int, when we say execute, it takes an int. Notice that 7 is the same. Like, let's say that instead of adding a third function, we also add the fourth, the fifth, and the sixth, right? 7 would be passed to all of them, to the third, the fourth, fifth, and sixth. So in this case, we have only one, just because I wanted to give you the example. But let's say, like, right away, quickly, we add the fourth. And yes, fourth. And yeah, we can just add it. And then 7 will be passed to both this and that. Okay, I messed up. Okay, to both passes 7. You cannot pass a different value, 7 to one and 8 to the other. It has to be the same, because they are in the same list in a sense, right? In the same delegate. And so now we go back to Unity. Okay, here we have a compilation error. Oh yeah, there is a bug in this version of Visual Studio that sometimes it adds that thing. Completely useless. It shouldn't do that. It gets confused, I guess. Yep. And we press play, so we imagine that we see first, second, third, and fourth, right? Yep. The first delegate prints these two, the second delegate prints these two. This is just junk. And there's another bug in Unity. It gets confused. I think the second time you do it, it doesn't happen anymore. Only after you recompile, sometimes it does it. Let's see if it is true. Yeah, even if it is enabled, it's still not there. That's it. That's all there is to it, really. It's not rocket science, as you can see. It printed all 4. I can show you one more. Press play. Wait a couple of seconds, and then it shows first delegate prints the first and second delegate prints the third and fourth. Why? Well, because we are telling it to here, right? The first and second are in the first delegate, and then we execute it. The third and fourth are in the second delegate, and we execute it. These are the 4. These two have void void, nothing nothing, and this has bool bool, int int. All right, that's all for now. Thank you.